Hi. Now we just talked about models and protocols and different rules, different suites, but there's still some groups that are responsible for setting up standards to make sure that all this communication goes consistently. Back in the 80s, even 70s and 80s, actually that's when I got involved in it, but if you wanted to have a computer system in your office, you chose a vendor and you used that vendor's equipment, their software, their interconnectivity between their equipment, and it was always one vendor's end-to-end solution. Of course, once you switch vendors, you had to switch everything out. Well, that wasn't very effective. So they ended up saying, hey, if we develop some standards in how we want devices to communicate, then I can swap out vendors. Different companies can get into different aspects. They don't have to be forced into knowing everything about all networks. They can just focus on just switches, routers, computers. They don't have to worry about end-to-end configuration. They just got to worry about, okay, who am I communicating in? What standard do I need to follow? There are definitely several different organizations, and you've got IEEE, you've got IETF, all of this stuff. All of these organizations have some aspect in playing with what we do. Now, the Internet standards, there are the Internet Society that does this, Internet Architecture Board. You've got different working groups. You've got there's just a lot of people involved. I mean, the Internet Society is responsible for promoting, open development and evolution of the Internet. The Architecture Board is just overall management of the Internet standards. The Engineering Task Force worries about making sure that updates and maintains TCP/IP technologies and stuff. And then you got your research side that says, hey, I'm always looking at long-term research related to the Internet and TCP/IP protocols and things of that nature. So you just kind of get a little idea of how complex all these standards are. So you may just want to be familiar with a few of those names. Luckily, you're not being tested all on this, but ones that we worry about a lot is IEEE standards, the Electronic Industries Alliance, EIA, or the TIA, the Telecommunications Industry, and then you've got the International Telecommunication Union, Telecommunications Union, Telecommunication Standardization Sector. It's just one of the larger standards body, but so just know that the standards are out there. Know that there's organizations out there that are trying their darndest to make sure that everything is consistent. So let's look at, I'm not going to let you go through, you can research those. I don't think I assigned that lab for you. I could have, but I didn't. I'm not going to worry about your knowledge. You will go through that. Now I'll look at reference models, since they're related to the organizations that create them. But because they're different standards, different type, and you saw, some basic layers to them, there's definitely some benefits for having a layered model when you're doing this. One is, I can just worry about operating at a specific interface, a specific layer. I don't have to know everything. So it kind of fosters communication. It prevents technology to changes from one layer to affect someone else. So I can make a change to my router as long as I know that the two other layers I'm interfacing with, as long as I maintain that interface boundary, I'm okay. So it allows a little bit more competition, a little bit easier to manage things. There are two basic models, the Open Systems Interconnection, OSI reference model, and the TCP/IP reference model. As I mentioned earlier, the OSI model it's more detailed, but because it took longer to get to market, TCP IP ended up being the de facto standard. But there is a correlation between the two models. And one, you're going to have to know the layers on both models and which applications fit into each layer. To remember the layers in the OSI model, I usually like to use an acronym. Programmers do not, let's see, is it? Programmers do not, it used to be like, transmission, yeah, if I think about it, I'll get it to you. But you got to have, so take a look, make sure, and the sequences is good. You need to worry about that. You're going to make sure you understand which applications or which transport protocols, what IP protocols, are in that network or internet layer. So you want to make sure you understand the different layers, applications in each of the protocol suites, and how it forms, how the layers compare to each other. I mean, you're only going to use the TCP IP, but to help us understand, there's a lot more data in the OSI model as far as intercommunication and types of things that get into play that you're going to need to understand. So the OSI reference model is I like to start at the bottom. Layer 1, that's your physical. It describes the mechanical, electrical, functional piece of how data is going to how's a 1 and a 0 going to be created. Then you got the data link layer. This describes how the exchanging for data frames are going to be between devices on a common media. So it's going to go from your PC to a switch, switch to a router. That data link, that connection between two devices is what you're looking for. Network provides kind of like the IP addressing set. It says I need to have an address to exchange information between the two. The transport protocol defines how you're going to segment and transfer and reassemble the segments on the other end. The session layer provides services on how it's going to be presented, how you're going to manage the data exchange, keeping that link still up. Presentation says, how am I going to present or represent the data between the application layer services? And then, of course, the application contains the protocols used for process-to-process communication. You saw HTTP, HTTPS, those are applications. Now, on the TCP IP protocol model, there's only 4. You got the network access, and it basically that all that hardware and media make up. Internet determines the best path, so it's a routing and addressing piece. Transport still worries about the communication between various devices, and the application still represents data to the users, how it's encoded in the dialogue with the user. So most applications we run, when you check an IP address, what it's going to see, you won't see an OSI address. You will see, I'm going to set up a TCP IP. Am I going to do IPv4, IPv6, and then what its address is. So when you do that, you're selecting which one of these you're doing. Now, comparing these two, there's a little bit of a quiz here as how to go through this. So I'll let you go through and practice with this, what the different layers are, what the numbering schemes are, what the names are. Practice, practice, practice to get that down. I would highly, I think this is the model, this is your homework assignment, 355, investigate TCP and OSI models in action. So there's in this case, I think I'm only asking for the Word document back, but go from there. So hopefully this gives you a rough idea between reference models and the benefits of it and the committees behind setting these up. So if you have any questions, let me know. Have a nice day. Bye-bye.